So last time we had our Minesweeper app and we had talked a fair bit about object-oriented things. And the primary reason behind that is that unlike some of the other programming tools and languages that are guided towards building us an engine, so to speak, let me get my picture up there. That's a little better. One of the things when we're building JavaScript we'll find and web applications is at the beginning we don't really have a framework we're using. We're not going to dive into Unity or Unreal and magically have a whole bunch of things done for us. We have to build everything ourselves. So when we talk about object-oriented software, we're also talking about breaking our software into layers, and those layers are responsible for different parts of the application. The topmost layer is that user interface layer, what the user sees, their view of the world. The next layer is that interface, or that object-oriented layer, that collection of things that we're manipulating in memory. And we need to keep those two things separate. And we keep those things separate so that A, we can replace that user interface at any point in the future, but also because we want to make sure that all of the things that we're managing in terms of memory, in terms of simulating our game or our game environment, are not polluted or cluttered up with things about the user interface. And the user interface stuff is not polluted about knowing too much about the rest of the simulation. As we go ahead and start to do that, we start to see in our code that we have a number of objects or classes that we create. Now, creating everything in one ginormous file is not really a nice, easy, conducive way to do this. So in a good traditional kind of language, we would break things out into separate subfiles. In C#, by simply declaring a namespace, everything in the same namespace, every definition in the same namespace, is included in the same application. They can use each other. If you have something in a different namespace, you declare the namespace and tell the application you want to use that namespace, and you get all the objects and classes within it. That's all those using statements in C#. In C++, the mechanism is to use include files. That hashtag include is a way of including a separate module. The header files define the API to those modules or those classes. So in JavaScript, we probably want something similar to that. And that's where we get into what we're going to talk today about modules and libraries. Now, of course, none of this works unless you really grasp the idea that for the web applications to work, they need a web server. To a certain extent, your computer understands that when you run an HTML file, that HTML file gets loaded on whatever program knows how to interpret it. Typically, it's your browser, Chrome. And the way that we trigger that on a Windows PC is we'll just double-click the file. But that breaks down really quickly at the moment we want to start loading in external elements, things we want to get from a server, CSS files, images, and especially with JavaScript. So we're going to need to run some sort of server, which is why I run that live server in the background all the time, to give me a test server to play with. Something I can bounce ideas off of and I don't have to control. When we start breaking our JavaScript into modules, this is especially going to be the case. Now, when we start thinking about how do we break this stuff up, we're going to use some traditional software ideas to break our modules up. And if we look at an HTML program, it starts with an HTML file, which is some simple structure to hang everything else off of. That HTML structure is what we use as scaffolding to try and keep our application in one piece. As we're building JavaScript applications, we typically will have one HTML file, and everything else will be driven by JavaScript. When we add a script, what we're doing is we're telling the browser to go get this file from the remote server. And the default way to add a script has no type statement in it like I've shown you. It just says, go get this app.js or main.js or index.js file and load it into memory and interpret it. Now, when we start thinking about modules, we're really trying to solve a specific problem. If you're using raw native JavaScript and you're loading scripts the way I have on this particular slide here, or you're putting type equals text JavaScript as you've probably seen on the internet a billion times, it will load a JavaScript file directly into the browser and start interpreting it right away. The problem happens when your JavaScript application needs multiple objects to load. You would need a script tag in your HTML for each object. And that kind of works when you have 2 or 3 objects and you know the exact order to load them in. But it breaks down really quickly as soon as we get to scale our applications. See this script tag that I have here? Imagine having Minesweeper with the application object plus something for the user interface plus something for the mine field plus something for mines. You've only got 4 objects. You have 4 script tags to put in your HTML. Now imagine you're doing a bigger application and there's 72 unique objects to load. That's a lot of script tags. It's kind of messy, and you have to get them in the right order. They have to be defined and loaded before they can be used. So this creates a problem with building large JavaScript applications. And we want to get around that problem with using a modern JavaScript module system, which we're going to use going forward for pretty much everything. Now, every module should be its own object, and it's going to get attached into memory as it's needed. That means the browser is going to be smart about not just fetching files as soon as they're specified, but fetching files just in time, exactly when they're needed. Every module is its own class. Every module is its own self-contained container. And the other thing that we do with modules is that the variables and constants and declarations in that module are specific to that module and that module alone, unless we explicitly export them and make them available to the rest of the world. So this gets us into a state where we can define individual objects and classes, put them into separate modules, and load the modules as we need them, and let the browser sort out what it needs when. And the upside we get is an easier to manage and easier to understand application. The downside is we got to do a little bit of extra work. And that little bit of extra work means we're going to structure our applications a lot like we do in C++ or in C# or any other object-oriented programming language. Every class gets its own file. The name of the file, capitalization included, matches exactly the name of the class. And then every one of those classes will have something that it exports that other people can see. Otherwise, it's not much use. We'll then collect all these things together in a main application and have the main application use most of these new modules. Now, when it comes to playing around with modules, I would be completely missing a large part of what you will actually see when you go out on the internet and look at this stuff if I don't mention that this is fairly new as in the last 3 to 5 years. And because it's fairly new, it's not the only way to do this. In fact, up to about a year, maybe 3 years ago, there was a competing module system. And part of the competition there was just that the native JavaScript modules didn't work exactly as specified. The Node.js environment has a different module system and only now has started to incorporate the native JavaScript module system. And that Node.js module system is referred to as CommonJS. And it involves a different syntax for loading external modules. And eventually I'll show you what it all fits together like. Okay. But these different ecosystems really came out of necessity. We had Node environments, which are server-side JavaScript running. And we wanted server-side JavaScript because we wanted to write the same language software on the server as we do in the client. And on the server-side JavaScript, we didn't have a truly functional module system, so the community created one called CommonJS. Very simplistic, but it worked. The challenge was that Node.js exploded, and so there's millions of software packages that use this module system. Then the native JavaScript module system emerged, it worked, but nobody went back and retrofitted the old module system. Now, these days, there's some idiosyncrasies around using some of that stuff. Well, let's take a look at the common module system, the module system that's native to JavaScript to start with. I'm going to start the live share up here. And you guys can see what we're doing. Let me put the link here in Moodle. Yep. Pardon me? Am I feeling better? I don't actually feel too bad. I was in the other day poking around. I don't sound great if I have to cough or something. You guys don't see it because I usually stack it up to when we have a break. And then I turn the microphones off and make bad sounds. I'm planning on being in there next week. And at that time I can infect you all, and that way you'll be immune. Right? No, it'll be good. All right. So I've got the live share running. I'm going to try and put it on my other screen. Well, this is our Minesweeper app from last session. And here's our main index file. Here's our JavaScript. And in our JavaScript, we have a ton of stuff that I've got collapsed. I've got a mine, I've got a mine field, I've got this grid square, this user interface thing, I've got an application, and then I've got my main program here. So today, we're going to use the JavaScript module system to bust this up into separate pieces. I'm going to start with the simplest, easiest one. So we're going to take this mine object, okay? And what we're going to do is we're going to start by creating a new file. And this is called a mine, so my new file is called mine.js. I've got my nice empty mine.js. Now I can just literally cut it out and paste it here. I'm going to add a couple pieces. First, I'm going to put this, that's just putting my name in the file. And then I'm going to do a couple things. First of all, at the very top of the file, I'm going to start adding a directive called useStrict. Now, that directive in JavaScript specifically tells the JavaScript interpreter to use the strictest interpretation of JavaScript and throw as many warnings and errors as possible. And this is to help in debugging. The second thing I have to do here, I have to export something. So we're going to introduce the export keyword. And when I export the class mine, I can now create my mine class and use it outside of this particular module. Right? Now, let's add a couple things to this constructor. Let's just put that in there. Something like that. Really simple little class. The key here is I want to export the class definition. I'm not going to create an instance of a mine. I am going to export the definition for it. And then over here in my index, I want to use it. So I need to import the definition for it. So way up at the top here, add that useStrict directive. I'm going to import. And here we're going to get into the funky syntax of it. In curly brackets, mine, that's the thing I'm going to import. From mine.js. Now, there's a couple key parts here. First of all, the period is required. Okay? You must have it. You must specify which folder to start from. If you do this, it thinks it's starting from the root of the web server, which is rarely where your application is. All the slashes, when we define files, just like in CSS, we use Unix slashes. And we do things the Unix way because most of the web servers are running Unix. And it's universal. Now, there's a couple variations on this. This gives us the ability to create new mines. And the definition's in an external file. It's in this mine.js file. I can go a step further. If this is the only thing, this mine object class is the only thing in the file, which it typically is if we're building object-oriented software, I can make that the default thing I export, in which case I no longer need the curly brackets. Now there's a lot of different variations on this import statement. We can do all sorts of crazy things. We can have that max adjacent. If I export that, I can import it here. So you can export multiple things out of a file, although typically we want to export just one. It's messy to import and to know what to import. I also typically get people to export just one default thing. So I'll get rid of that. And in fact, some of these constants, I will use some fancy JavaScript to make them part of the class. I will use a getter to pull them into the class definition. You could do something along those lines. We use the get something like that. Now I don't have to pull in max adjacent this way, but I can simply refer to, let's do this. Let's add this to your repertoire. When I add the keyword static in front of a get or set method in JavaScript, that means it's a class method. It's attached to the class. So I can attach it to mine. Get means treat this as if it's a property. Static means it's attached to the mine class, not objects created from the mine class. So in this way, I can break my software out into separate modules that we can use. So at this point, to make our lives a little bit easier and to make our JavaScript files a little bit smaller, I'm going to break apart my JavaScript here into a couple additional modules. First, I'm going to leave my mine alone here as a nice template. And the next thing is I have this mine field. So I'm going to create a new file, mine field.js. Put in my name and the use strict. I'm going to go grab this mine field object. Put it inside my minefield.js and add the export default. So now I have a separate module called the minefield. Back in my index, I'm going to go back to the top. There we go. Now the interesting part of this is that if I don't use the mine anywhere in this index.js file, then I don't have to import it. If the mine field needs mine, then the mine field can import it. And the import system takes care of loading the right things at the right time for the right module. So for each module, you import just the things you need and just the things you're using. One of the ways the editor tries to help us here is you'll notice it's kind of grayed out on the mine field, and that tells me that nobody is creating a mine field inside this file. Now I'm going to carry on and make this go a whole lot further. I'm going to take this grid square and pull it into a separate object, separate class. So I'm going to create a new file, gridsquare.js. Copy my name and the use strict. Take my grid square. Put that in there. Add the export default. Now this uses mine. So we'll import it. This doesn't use the mine or the mine field. They're buried inside other things. And we can go a step further. I can create an application object. app.js. And I'm going to take this whole application class. And paste it in there. Export default. And then we can import anything we need. So let's say I need the mine field. Now, of course, if I create this all in a minefield object, I have to change the way my minefield's built. And now what are we left with here? Not much. And that's really all we need in our application. Breaking things out with modules. Why is this preferable? Why is this a nice way to do things? Yeah, that's absolutely one of the best reasons. It's very, very easily organized. I'll give you a couple others. Does anybody think they would have a problem debugging this much code? It's pretty hard to get this wrong. I mean, if you assume that the application just works, creating a new application and telling it to run, all the work's done by the application. This particular file, it's really hard to get wrong. And in fact, we're going to try and strive to do that everywhere. Let me just rearrange them here. In the application, I might have a class that's relatively large, but I'm trying to get every method to be small enough to fit on the page. Everything that's small enough to fit on the page is a small number of statements. And every time we have a small number of statements, we make it easier for ourselves to debug things. Easier to debug means we're working more often, which means we're spending more time doing the fun stuff called creating and building, and less time doing the horrible, ugly stuff, which is trying to debug things that don't work. Now, this is all triggered by our index.html. If we look at our index.html, the magic that makes this module system work is the type equals module on the one script that is the starting point for the whole thing. It's like pulling on the thread of a sweater. If you load this one script, it will load index.js. And it will load it as a module, which tells the browser that as soon as you need something, go get it. And so when it loads index.js, the first thing it runs into is this import. And when it runs into that import, it says, oh, okay, I'll make note of that. And then it runs these lines of code. And then it gets down here to go, oh, I'm going to try and create a new application. And I know where application is coming from. It's not until it runs this line that it sends a request to the server to go fetch the app.js file. And once it fetches that app.js file, it interprets it. And the first thing it has is an import of minefield. So it says, okay, I've made a note of that. And then it loads the definition for your application. Nothing's executed yet. It comes back to our index and it triggers the new keyword, which calls the constructor that we just loaded. And in the constructor, we start to execute this code. And if any of this code needs the minefield, it'll go fetch it when it needs it. And in this case, we're going to call initialize mines, which is going to drop in here. And the very first thing it's going to do is create a new minefield. So it's not until this point where it will trigger a request to the server to go get the minefield object. This is called just-in-time interpreting. And it's what makes websites and web applications faster these days, because we're not fetching the whole application right up front. We're not waiting for it to all download. It also means if you try and do this and you don't have a web server running, you're going to run into errors, because it's not going to be able to find the files because there's no web server to retrieve them. Now that import-export mechanism is what we're going to use for all of our object-oriented software going forward. We're going to build the whole suite of applications we build by creating an HTML page. At the bottom of the HTML page, we've got some structure, and then we're going to add a single script tag to load our main program, typically from index.js. In that index.js, we're going to import modules we need, typically an application. And what I tend to do to keep it straight in my own head is the application object manages the user interface. That way I'm not hunting through minefields and mines to find document query selectors all over the place. All of the document query selectors live in application.js and nowhere else. All the data lives in separate objects. And the task of breaking things apart pieces like this is what we refer to as software architecture. This is what we mean by building software out of layers in a specific architecture. We have some data. We encapsulate that data in some objects to provide some additional functionality. And then we export those functionalities to a layer that presents it or gives a view of it to the users. And we'll formalize this as we go further into the classes. But this is the exact same architecture that all of our game engines use. And in fact, most event-driven, user-driven applications use. Now, this module system really works very, very well. It does, however, have a few places where people haven't used it. And I can tell instantly when people are pulling stuff from the internet, because a lot of the stuff on the internet uses the common JS module system, which looks very different. It involves a require statement and loading in a separate library. And those require statements work in the same way as the module system, except that they're not dynamic. That is, when your application loads, the common JS style modules load all the modules up front. Now, All of these exports might feel like they're going to be really hard to keep track of, which is why I typically have just one export per file. So every module is a file. Every file has just one default export. Every file contains one object. Class is the thing we export, and we try and bake everything into that. The goal that we have there is to try and keep our software clean, to have a nice, well-defined interface into each of our components or modules, and to be able to pull external modules into our application as we need them. We import just what we need as we need them. Right? Now, the other thing I do have to warn you about is if you go online and look for some assistance and help with a lot of JavaScript programming, you'll find a number of false statements. The biggest false statement is, oh, we have to use an older version of JavaScript, notably what they call ES5, because browsers don't all support ES6 and the module system. And that's just plain false. Okay? Those are articles written by either people who don't know, or they're written long ago and they're still hanging out on the internet. But if you don't want to believe me, we're going to go take a look. There's a website called Can I Use? Let's see if I can bring it up real quick. Literally called Can I Use? So if I look up, say, export, it tells me API, JavaScript statement export, which is the one we're interested in. And it tells me for every browser what version of the browser supports it. And the main line here, the one that goes across all of them, is the current version. So we can see that Edge, Firefox, Chrome, Safari, Opera, Safari on iOS, Android, Opera Mobile, Chrome for Android, Firefox for Android, and the Samsung Internet Browser all support imports and exports natively. No middleware, no transpiling or compiling into something else, no BS about this won't work on older browsers. It's supported everywhere, universally. If you're an Opera fan, get over it. Opera is kind of like the least supported, least functional, least feature-filled browser if you start digging through this kind of stuff. And you can find out how much is supported just by hovering over these things and which particular version at what date. Right? And we can look up other things as well. Let's say we look up class. Because again, somebody says online, hey, classes aren't supported. You have to do them this way and transpile them with Babel. Well, no, actually, except for Opera, all the major browsers support classes out of the box. Or const. All the browsers support it out of the box. Or let variables. Again, everything but Opera Mini. Right? And given how small an audience Opera Mini is, we just abandon them. So we want to use modern JavaScript wherever we can. All right, let me summarize some of that stuff for you here. In your HTML file, one script tag, loading index.js, type module. That triggers the whole thing. In a class.js file, where the class name matches the class inside the file, we're going to export default the name of the class. We can export external things and other things. Typically, I try and avoid it. And then in our main module, in our index.js module, we can import the thing we want to use and then just start using it. Okay. So exports from a module allow us to import them somewhere else. Imports, you import only what you need. So don't try and go into your application class and think about every object that you're going to need in your program and import all of them in your application class. If your application class doesn't explicitly use something, don't import it. If in doubt, leave it out and let the debugger trap it for you. When you go to run it, the debugger will say, hey, that's broken. I think mine's broken right now. See, it's broken. Doesn't work. Bring up the inspector. And we see there's errors. No mine is not defined in minefield.js on line 17. No mine is not defined. So I'm using mine and no mine. That's these guys. Minefield. That's where they belong. Field not defined. Field, this dot field. We gotta go fix all our errors. Column size is not defined in app.js. Yeah. Okay, so you go one direction. So the app can use the minefield. Minefield can't use the app. Okay? Right. Right. Now there's two reasons for that. One is not a software technical reason. Technically, with enough massaging of the imports and exports, I can get them to import and export each other. Syntactically anyways. The problem is, as soon as I do that, I get the app needs the minefield, so the app loads the minefield, and then the minefield needs the app, so the minefield loads the app, which then needs the minefield, which then needs the app, and you get into this loop, right? So it has the interpreter has a really hard time knowing where to stop. It's a cyclic dependency. You can't do it in C++ and you can't do it in C# either. All right. The second reason is a little bit more architectural, and that is I want my application to know about the screen. I want my application to know about mines and minefields. I don't want my minefields to know anything about the screen. I want to be able to rip that minefield off and go put it in another application. Now, the minefield's a bad example of that. But there are times when I build things like data structures. You know, let's say I want to build a quad tree structure. I'm going to build that in a class. And as I use it in different applications, I want to be able to lift up that object and just drop it into the new application unchanged. And the only way that works is if that quad tree knows what it needs, looking down and in, but it doesn't know who's using it. It doesn't have a reference back up. Does that make sense? Okay. So when we think about our Minesweeper app, an application is dealing with the user interface. It's going to have all our ties into event listeners. It's going to have all our ties into the DOM and updating the screen. Okay. But it's not going to need to know anything about mines or mine fields. The mine field is really kind of a data structure. And so we're going to fill up the mine field with a bunch of mines. And every time somebody does something in the user interface, we want that application to go ask the mine field, hey, is there something there? Oh, there's nothing there. Okay. And then the application has to figure out, what do I do next? Do I reveal the cell? Do I flag the cell? What do I do? That's a user interface thing. Oh, I need to ask the adjacent cells whether there's something there. Okay, back to the mine field, ask the mine field. Do you have adjacent? How many adjacent things do you have? I mean, any of those questions or actions you can ask are methods you would add to your mine field. So your application's driving based on user input, and the rest of your objects are really there to help create that simulation, that data store. If that kind of fits. Okay. Now, I've showed you a really simple import-export example. When we start looking at all the different ways you can import and export things, the definition of the import-export mechanism defines a number of different ways to import and export things. And here's a whole bunch of the different ways that we can do it. Sometimes these are of great value. So you should just know if you see them or if you have some particular need. The ones with the import statement here at the beginning are the kind of traditional ones. The first one is importing the default thing. The second one, where it imports count. Count is not the default. It's just an exported constant. And remember, by convention, we make constants all uppercase. The third thing, right, that we have here, drag that out of the way. Okay, the third thing that we have here is, again, we're importing things that aren't the default. The next ones get a little bit interesting. Import star as name from class.js. You can rename things as you import them. Import everything as grid area from minefield.js. And that will rename minefield to grid area. Okay. It's rare that you want to rename something that way, but it is possible. You can also create aliases as you import things. Those aliases are helpful if you want to shorten the names of things. And there are some instances where we have really long-winded names on things, and when we actually use them, we want them to be quite a bit shorter. There's a bunch of other variations here that have to do with some operators I haven't taught you about yet, things called rest and spread operators. When we talk about rest and spread operators, I'll come back to some of those. And the very last one is the dynamic one. In other words, when the imports get triggered is on the loading of the modules. When you load your HTML, it triggers the first module to import, and they get imported as they get needed. There are rare times when you need to control that yourself. And using import as a function allows you to manually control those things if you need to. All right. So the task for you right now, we're going to take a 10-minute break. I'm going to come back at 5 after 10. And in the meantime, I want you to go through your applications and break them apart into modules the same way I did. So every object goes in its own file. The class definition, you put export default in front of the class definition. And where you use it, use import class name from /. file name. All right. All right. I'll be back at 5 after. All right, how's it going breaking those things up? Has everyone got their modules broken up into separate files now? Cool. Cool. So if you've got some of the basics working, I'd like to introduce to you the idea that you don't have to build everything yourself. And specifically, most of the JavaScript language is at your fingertips right now. It's not that complicated a language. But all of the value in most programming environments comes from using libraries. You know, the people that go before us typically do a really good job of building things that might be of great value to us. And in our case, this is absolutely what we're going to take advantage of. Right? So we don't do this stuff in isolation, right? We want to be able to use third-party libraries. We want to be able to use things that other people have built so that we can make our applications more interesting without having to write everything from scratch ourselves every time. And to do this, we're going to use some libraries. Now, libraries typically contain some objects or functions with some additional functionality, and the real challenge is just learning how to use them. I mean, when you're building C# applications, 90% of the work is figuring out which C# libraries to use to represent a lot of the things you want to do. And just like in C#, there's a huge suite of libraries we can pull from in JavaScript. In fact, it's the largest development community out there, by far, is JavaScript components. And you'll find more trouble in figuring out what's the right or the best component for you than you will actually writing your own stuff. So there's a few things we need day in, day out. One of the things we all need and will continue to need is basic mathematical functions. And JavaScript has a math library built into it. There's an object called math, capital M, and the math library has a whole bunch of static methods attached to it. That is, methods that you use capital math dot and then the method name. And these math methods are things that we use all the time, in particular trigonometry, doing any sort of rounding of values, so floors, ceilings, absolute values, doing exponential powers and logarithms, and of course, random number generators. As we know in all computers, the random number generator is really just a really long sequence of pseudo-random numbers that are generated through a function, and that function is typically seeded or started with a very specific value. And if we choose a value, we can control the sequence. And if we don't choose a value, if we just say, take the current tick value of the clock of the computer that you're currently running on, then we get what appears to a user to be random values. The math.random method in JavaScript returns a value between 0 and 1. It's a floating point number, which means you can manipulate it any way you like to get the kinds of values you want. And if we want to guarantee that it's, say, an integer number, we would use another math function like the floor function to truncate all the decimal part. So in this way, if you want to randomize where your mines are, you could, while you initialize them, say, hey, I want 10 mines in my mine field. Let me walk through a for loop, and for each mine, I want to randomize the row and column that it's in. And just straight brute force, you could go, hey, if there isn't a mine there already, put one there, and reduce the number of mines I have to set by 1. And if there is a mine there, just go randomly pick another spot. And in this way, we can use the math library that's built into JavaScript to randomize some of the things that we're doing in our application, our game. Now, not all the libraries we're going to use are necessarily things that come built into the JavaScript libraries or into the JavaScript environment. In particular, there's a couple things that we're going to want to do in our game to make it feel like a game. One of the things that games have as a kind of universal idea is the notion of feedback to the user. The user does something, and we feed back the results to the user. And that feedback typically comes in the form of 4 things. I do something. The feedback I'm going to get has something animate. It has something in the UI that changes, a score, HUD element updates, whatever. It usually has some sort of visual effect, and it usually has some sort of sound or audio. In your Minesweeper games, I expect your games to have audio. So when we put audio in, I also don't expect you to write it from scratch. I want to use an audio library. Now, I'll give you an idea of the kinds of things we can get from libraries, but to do that, we need to know how do we pull third-party libraries into our JavaScript applications. Now, this is a place where we can actually use those script tags. Because we're pulling third-party stuff in, there's 2 ways we can do it. We can download the library, which would be downloading a JavaScript file, and put it in our scripts folder, or a subfolder underneath that if we want. And we can load it with a script tag. In these particular cases, what we want to do is we want to load those things in the head section. So we want to put a script tag, source, and then the location of the JavaScript file in the head section. The reason we do it in the head section is it's a third-party library. We have to expect that it's going to work. So we don't need to worry about it crashing on us. Now, if you know you're going to be connected 100% online all the time, and you don't want to download a copy of the library you're going to use, but you want to just refer to it somewhere out in the world, you can use that source attribute to specify a fully specified URL, HTTPS, // and then the full URL to where the JavaScript file lives. Typically, it'll be on some sort of content delivery network. And we're going to do a little bit of both here. Okay. Now we're going to take a look at some of the libraries that you can do things with. And these aren't related to Minesweeper, but I just want to give you an idea of the kinds of things people build as libraries. So let's say you're going after a JavaScript front-end programming job, and they want to see how good your JavaScript is, and you want to present yourself in a nice way. You might decide that you want to do a version of your biography or of your resume in a very nice, slick way. And you want to do it in JavaScript. So you employ deck.js, which is a JavaScript library which mimics slide decks, just like we're doing PowerPoint slides, where you can use the arrow keys to flip through your deck. And maybe you want to use this deck not just to promote yourself, but maybe you're working for a company that's trying to get a contract and you want to prove your proficiency. So you can build HTML and then attach this deck.js, and it will use a bunch of classes that you attach to specific sections to make each section appear like its own slide. And you can just flip through these kind of things. You can add little controls. These are all part of the library. You can make all sorts of fancy transitions, all part of this library. If you want to use it, you would download it. And when you download it, you'll get a deck.min.js. Now that min part in the file name you keep. What that means is they've compressed the file so it loads faster. They've also removed all white space in the compression, and they've renamed all variables and all functions to be single character, single letter, ambiguous names. It'll still work the same way, it just won't be very readable. And they keep that so that it's easier to download and manage. You would download this into your scripts folder. You would then use a script tag to load it from your scripts folder. And then you would have to read through the documentation to find out, how do I initialize a new deck? Initialize a new deck, $.deck, selector, options. And the deck uses a selector to find out which HTML elements to think of as a deck. And then they have a number of other options here where you can build menus and navigation, update your status. Again, all of this sitting on top of your native JavaScript. Now, if deck isn't very impressive to you, let's go to something that's a little bit more impressive. As a JavaScript library, this library gives you one visual effect, and that's it. And what's the visual effect it gives you? Well, in their little demo, I can click on this and it opens it up. It's a page turn book effect. In fact, this is all done with JavaScript. And it even does both sides of the page. Now, I don't know about you, but the idea to me of sitting down to write that is both challenging and very time consuming. It's a very cool effect. And it's a whole lot easier for me to just incorporate the library and use it than it is to try and build it myself. Funky, right? Yeah. Now, do we want to write that JavaScript? Someone else has already done it and debugged it. Now, the best place to find these kinds of tools and libraries we'll find next term. We're going to get into how do we get a hold of some of this stuff. But you kind of have to know what you want to do. In our case, one of the things I want to do is audio. And this is the library I typically use. This guy, Jay Salvat, has done a really good job with an audio library that gives you a large number of the capabilities that we would ever want with audio. It's got really nice documentation, and it hides the audio tag in HTML inside the library. And his fee, I've thrown him some money. His fee is buy me a beer, which I just think is brilliant marketing. So here we go. if you want to load it externally, there's the URL to load it from. So if we go to our code and we go to our index.html, I'm going to copy this. And then up here, I'm going to load it. I'm going to put the quotes in the right place. Don't know why I did that, but... And that's all it takes to load that audio library. Technically speaking, when you load it from an external URL, you can just use that. The HTTPS is implied. Okay. You'll also notice it gets loaded from Cloudflare. Based on our discussion the other day, Cloudflare is a content delivery network. This guy's uploaded his library to a content delivery network that has servers around the globe. So whenever you load it, it loads it from the closest Cloudflare server to you. They all get mapped behind the same URL. Then we have an example in the documentation directly about how we can use this library. So the next part is you're going to need some audio. Now, with this library, I've already checked out the specific licensing requirements for this library, which is for educational purposes, you can use it. No problem. Okay. For commercial purposes, buy the man a beer. If you ever get to that point, right? Whenever we're using a third-party library, you do have to go check the licensing requirements. Where are you allowed to use it? The results of not getting the licensing correctly with most software applications is really simple. It's if you make money on something using somebody else's library of stuff and they sue you for it, they're entitled to the money. So if you make $1 million on a really cool game that uses this audio library and he decides to sue you for it because you didn't get a correct license from him, he's entitled to a percentage of that $1 million. And the courts will decide how much a percentage. Could be all of it. Or you could just buy him a beer and license it correctly. Right? Now, that's for that particular library. What I'm saying is you have to read the license agreement on every individual separate library component you use. A lot of the components we use here are what we call MIT licensed, and that is free for educational purposes. You can use it as much as you want, any way you want, any how you want. You can't come back and say, oh, you broke my software, you're to blame, you're on your own, but you also can't use it commercially. Right. Now, when it comes down to the audio itself, you absolutely positively can't use anything that's stolen, pirated, or illegal music-wise. When it comes to your Minesweeper game, I would expect sound effects when you explode something, like hit a mine you're not supposed to. I would expect sound effects when you clear an area. I would expect sound effects or maybe some background music going the whole time. And it would be great if there was some user interface for me to have some settings that I can control. So a dialogue in the middle of the screen that's my options dialogue that lets me change the volume levels on things. Now that's not that hard to do if you take a look at his API. If you take a look at his API, you create new sound objects using buzz.sound. And from there, you can tell those sound objects to play. You can preload them. You can autoplay them. You can loop them. You can set the volume level. So it shouldn't be too hard to in the constructor of your application, create something that loads up some sound effects, creates them in sound objects. And then when certain events happen, you tell the sound object to play itself. If it's a short little sound effect, it'll just play. The beauty of this library is it does the mix nicely. That is, if you have 6 sound objects and you tell them all to play at the same time, it will overlap them nicely. You'll hear all of them. Of course, it's up to you to kind of balance the volumes between them. So 2 or 3 things is fine. So plan on this for your Minesweeper app. Plan on doing some audio for your Minesweeper app. Now, this isn't the only library that you have access to. There is another library that's out there that is probably the most common, most obvious library that you will ever run into. It's not the biggest thing anymore in terms of the biggest library you'll ever run into. It's at one point it was the thing everybody used. And the library I'm talking about here is jQuery. And jQuery as a library is really a helper library to help you manage the DOM. And part of the reason it's not so popular anymore for new applications is that about 80 or 90% of jQuery's functionality is managed by native JavaScript these days. So it's often not required. The one thing I'll tell you is if you're going to incorporate jQuery in your Minesweeper app, use it consistently everywhere for everything. If you're not going to use jQuery, fine. It's not going to affect you in any negative way. You just have to get around using normal, everyday JavaScript. The things that jQuery does for us that we're going to get into, it manipulates the DOM more easily. It allows you to do mass operations on lots of parts of the DOM simultaneously. Its biggest advantages, the things it can do well, animation. It can do a very good job of talking to remote servers, which we don't need till next term. And it can do a very good job of managing multiple things that are animating at the same time. And doing that in a nice, clear way. Now, some of the libraries I have listed here, I've shown you. Some of the libraries are replacements for certain parts. So jQuery is this kind of all-in-one library. It's relatively tight and compact. It's been around forever. It is super fast. It is relatively small. It is completely debugged. So you're not likely to have any errors with it. The combination of Lodash and Axios can provide you with most of the functionality that jQuery has, but broken into a couple pieces. Buzz does audio. There are a couple others. Turn and Deck have some very special effects, as I've showed you. So what I suggest you do now is take a few minutes, go to that buzz.js library, download it, because it's probably easier to download than to use the content delivery network, and incorporate it into the head section of your application. You don't have to use it at all at this point. Just make sure you load it with a script tag and that it doesn't throw any errors when you run your application. Okay. Once you do that, the next part is to go out on the internet and go find a couple audio files that are free to use. And David can direct you at a couple of the sites. We do have access to some of the 5-alarm stuff, I believe. There are sites that have sound effects you can use. You just need to make sure that you've got free sound effects. And once you grab a couple of these sound effects, put them in an assets folder underneath the main folder for your Minesweeper, and see if you can't create a sound using the Buzz library and create a button on your page to test it. Put a button in your application like the Play Now button and have it play a sound. You can use the documentation and the tags there to actually load a sound and play it. And typically I load the sounds in the constructor, and then I use the API to play, stop, pause, whatever I have to do later. All right. I'm going to give you about half an hour now to do that. And then in the last hour here, we're going to talk a little bit more in depth about jQuery, so that you have it as an option. It's one of those optional things you can use in your Minesweeper app if you find it easier. All right. So I'll start up at about 11 again. Check the live share if you want to see how to link the library. All right, you've had a little while to see if you can integrate a sound. Has everyone been able to get the sound to play? Are there any challenges with that right now? So a couple things you'll need for your game. The math.random you'll need to randomize where the mines are. Figuring out adjacent mines is something that's up to you. Whether you want to figure that out dynamically, like as the player's playing, or whether you want to pre-compute it and put it in a minefield object, that's entirely up to you. When you start clearing mines, how you do that is something that you're going to have to figure out. Right? When you do that, it's nice to have some feedback, so do take advantage of that audio library to try and give some beeps and squawks, some positive and negative feedback to the user as they do things in your game. Now, the stuff I'm going to show you now is all about jQuery, and jQuery is a library to help you do things with the DOM a little bit easier. Has anybody worked with jQuery before? Good. Okay. So the biggest difference when we talk about jQuery is that when you're working with native JavaScript, the document query selector, which is roughly based on jQuery's selection mechanism, the document query selector returns the DOM element you're manipulating. jQuery doesn't. jQuery returns a jQuery object. And in order to keep that from being really confusing, what I suggest is you either do everything with jQuery or you do nothing with jQuery. Right? And again, as far as grading the applications go, I don't care which way you go. Just be consistent. What does jQuery really do for us? Well, let's get into it. So, first and foremost, it's a separate library that we incorporate into our application. It's been around forever, and as such, it has some pluses to using it. The biggest plus being it's been around forever, which means it's rock solid in terms of stability, in terms of bug-free, in terms of actual usability. It does a lot of stuff, and you see jQuery all over the place. You'll recognize it right away because it's a little bit of software that tries to do stuff with the DOM in a nice, easy, consistent way. Like most libraries, it provides us with a bunch of capabilities that let us do things that otherwise would take us a lot of time to build ourselves. And when you integrate the jQuery libraries with your application, which you do exactly the same way as you do with Buzz, you load it in the head section, you can manipulate all parts of the user interface all at once. And we'll show you what we mean by that. Now, jQuery typically used to be the cornerstone behind every kind of JavaScript application. Everybody used it. It was kind of universal. And so a lot of times when people first start looking at JavaScript, they don't separate out what's jQuery from JavaScript. And that's part of the reason why I showed you most of the JavaScript stuff first before we got into doing any jQuery stuff. And going forward, we'll use it in a limited way because it does have some really nice capabilities that aren't easy to find in other places. But as far as this assignment goes, it's completely optional. Right? So we can load it locally. We can go to the jQuery site and download the latest version. We can load it from a content delivery network. It's broadcast all over the place. So Google, Microsoft, Cloudflare, they all have versions of it. jQuery themselves have a version of it. That'll be the jQuery.min.js you download. And if you want to download it locally, you put it in your local scripts folder. I typically put third-party libraries in the lib folder underneath my scripts folder so that if I need to update them in the future, I know the folder can be updated or purged or blown away, and I can get it from the internet again. Technically speaking, when we start doing Node.js applications and client-server applications, you can install it as a Node package. We'll get into that next term and what it's all about. The link I have here is the way we load it into our head section through a content delivery network. The version may not be the latest. What is the latest version of jQuery? Let me go look. What's the latest version? 3.6.0 is the latest version. So just replace the version number with 3.6.0. And you can incorporate that directly into your head section. So I'm going to go to my CDN. I'm going to put that in there now. I'm going to load it first. And I'm not going to load it locally. It's it from ajax.googleapis.com/ajax libs jQuery. .6.0 jQuery.min.js. Should just work. All right. So, what can we do with this thing? Well, jQuery starts, jQuery starts with a jQuery function or object constructor, and it's literally called jQuery. So if I go to my app.js here, or better yet, my index.js, right, I can create a jQuery object, and probably just like that. Now, what do I do with that jQuery object? Well, not really much. That jQuery object in itself doesn't do anything. It does have a lot of methods attached to it. The jQuery object has one parameter, and that one parameter is a string. And that string is a selector. And that selector selects part of the DOM. And it returns a jQuery object. So think of it like a constructor. If I go put this inside my application, again, doing this in here, in my application here, and I go grab the output field, this is the typical way that we would use jQuery to create an output object, which is a jQuery object based on the item or the DOM element that has the ID output. Right? Now, once we have that output object, we can now use any and all of the jQuery methods on that object. Now, if you notice, the jQuery object constructor takes a single parameter, and that parameter is a selector. And it's not a coincidence that document query selector is preferable if you're going to use native JavaScript, because it's based on jQuery and it uses exactly the same selectors that jQuery does. It works in exactly the same way that jQuery does, except that instead of returning a jQuery object, it returns the DOM element itself. Inside that jQuery object, you can access the DOM element. The jQuery object also has a shortcut. And the shortcut you've probably seen all over the place. You see, programmers are lazy, and typing jQuery all the time seems kind of like a lot of typing. So there's a shortcut that's built into the jQuery library for initializing a jQuery object. The shortcut is this. If you ever see that $ with a selector in any JavaScript temporary sample code, it's actually using jQuery. That is the jQuery shortcut. Okay. It is not part of JavaScript. It's a separate library. But it does make life really easy. Now, if I wanted to take that thing and call some jQuery method on it, I could, by now taking the out object and calling a jQuery method like, say, hide. So now the output element, we create a jQuery object based on it, and we tell that element to hide itself. Now, if we collapse that up in a traditional kind of JavaScript chaining, we get something that looks like this. Now, using that one method, because I know jQuery has a hide method, I can now, in one statement, hide an entire element. And if I were to remove this one and go down into my initialize in my query selector here where I hide and show, I can now replace this with jQuery. That's the jQuery equivalent. Native JavaScript, jQuery. Which one do you think is easier? But right now I've got this problem that I've mixed the two of them together, which is a little bit challenging, right? So first and foremost, the jQuery selection mechanism is exactly the same as the document query selector. The query selector returns a single element. There's a separate method call on the document called query selector all. If you're selecting a selector that's a class or a tag, you may want to use query selector all. It returns an array. If you're grabbing, say, all of the TD elements and you want to do something simultaneously to them, you would use in JavaScript, you would use document query selector all the TD. jQuery combines those together. If you want to, you can use anything you want in the selector for jQuery because it returns a jQuery object. And the jQuery object always contains a list of matching elements that match the selector you gave it. Any jQuery methods you call get applied to the entire list. So, for instance, if I wanted to change some part of every TD element in native JavaScript, if I'm going in here and I want to set up, where do I set the table here? Create table markup. There we go. That create table markup there. Let's say I wanted to go in when we show everything. And now using JavaScript, if I want to modify every TD element, I'm going to grab all of the TD elements class list. I can add some style to them. And that grabs all of them at once. And the jQuery equivalent of that looks like that. Now I'm showing you some of these standard examples so you get the idea that pretty much anything you can do with jQuery you can do with native JavaScript and vice versa. Sometimes JavaScript is a little bit more expressive. Sometimes jQuery is a little bit shorter and easier. More specifically, jQuery is a single constructor that takes a selector and returns a jQuery object. Do not get the objects confused with the elements. The $sign is the shortcut for the jQuery constructor. You can use anything in the selector, and then once you have jQuery objects, you can use any of the jQuery methods, and we'll go to their website. You can see an idea of some of the methods. Now, the typical things that we have, we're adding classes and removing classes. We're retrieving the values of things. jQuery has the ability, the HTML method on a jQuery object does the same thing as setting the inner HTML property of a JavaScript element. The append method is something that only jQuery has. In other words, you could set the HTML initially and then append to the end of it as you go. The other thing that jQuery has is that when we start our application up, we load all our HTML. And as we load our HTML, we're going to load some JavaScript in the head section. We're going to have to wait for that to load. And there is, in some cases, a possibility that we're not finished loading the HTML when the JavaScript starts loading. And in that case, we want to do something to wait until all of the DOM content is loaded before we go ahead and load and execute our JavaScript. And both native JavaScript and jQuery have a way to do this. The jQuery one is more robust. The native JavaScript one is kind of cheap and cheesy. If I take a look at my editor here, the way we do it with native JavaScript is we add an event listener to the entire document. And the event we listen for is DOM content loaded. And we put our code inside there. Now this guarantees that all of the DOM content gets loaded before we create our application and start running. The jQuery equivalent we grab the entire document. No, jQuery, that's not it. Ready. And it doesn't take a function, it's a fat arrow function. The jQuery equivalent looks like this. Wait till the document's ready, and then go ahead and execute my code. So choose one of those two to put in your index.js. The document ready event actually waits for every request to the server to complete before it loads your JavaScript and starts running. It just holds it all off. Now, there's a couple other key jQuery methods that we want to get access to. Obviously, the HTML and append method are the ones that are going to let us construct HTML as we go. Also recognize that if you ever call a jQuery constructor with, instead of a selector, but some HTML in the middle, it will create a new jQuery object using that element. It doesn't mean it's attached to your page yet. You would need to attach it to some other element. But it can be really helpful to build things offline or build things out of sight and then attach them to your page. So in our application here, I can come in and create I'm going to flip it in a sec. I'm going to create that new markup, and I can do it right in jQuery. And you can immediately see the problem I'm going to run into. So, new markup is a jQuery object. It's not attached to anything. It's not on my page yet. I haven't attached it. And because of the quotes, it's a little confused right now. So I'm going to simplify it because of what I'm doing. I'm just going to use a single quote, so it's a string literal. And I'm telling the interpreter, don't look inside the single quotes, just take it as is. And you can tell by the syntax highlighting will help you with that. If it gets more complicated than that, I'll use my favorite backticks and parameterized strings to make it look good. If I want to attach that to something, I now have to go find some other element. As you can see the suggestion here, I can go find my game screen and append to the end of it this new div. So in this way, I can use jQuery to create new elements as we go. Right. Let's take a look at the jQuery site itself. Literally called jQuery. And in here, you've got a big download button, so you can download jQuery natively and put it on your machine if you want, or you can go grab the URL to get where it's coming from. What we're really interested in is the API documentation. And in the API documentation, some of it's a little old, so they'll have function keywords all over the place. We're going to replace those with fat arrows. Those are functions that are callbacks embedded. And what you get here is the list of all of the methods attached to every jQuery object you create. All of the methods attached. There's a lot of functionality here, and knowing which piece to use is a matter of looking through the documentation. But you do have some that are fairly straightforward, like the hide and show methods. You can also play around with any of the CSS. You can ask it what classes it has. You can retrieve the DOM elements from within the jQuery objects. Where do we go here? The data attribute is another one we can look at. And as we look at the data attribute, it gives us an easy way to attach information and to retrieve that information from our elements. The other thing we get with jQuery is we get an event handler system. So we replace the add event listener with one of two things. So first of all, I can go to the click method, where I just add the handler. Or I can use a general purpose method in jQuery, on. Not one, on. On an event. So I'm going to go through some of my code. I'm going to flip everything to jQuery. And you can start to see how we look up the methods to make this kind of fit together. I'm going to start with my index. I've already converted that to jQuery. In my application, this is where I'm going to do most of my jQuery stuff because it has to do with the user interface, which means I shouldn't have to touch any of my other objects here. All right, query selector, I'm going to replace this with jQuery. And then inner HTML is replaced with the HTML method. Yep. Can you say that again for me? Yeah. You can use both, either the HTML or the append with jQuery. I'll show you as I replace the pieces. So the inner HTML is going to be replaced by the HTML method. Nothing really changes there. Right? I don't have to change that. In the event handlers, I'm going to replace them with the jQuery equivalent event handlers. So the first thing is I need the selector. And then jQuery's equivalent to add event listener is much shorter. Right? And I can do the same thing with this guy. It passes the same parameter in. Now with those two methods, I have some stuff going on inside here. So here, I'm going to hide this screen. Using jQuery's hide method. This stuff is all demo stuff. We don't need any of that. So eventually what I want to do with that is I want to delete it all. And now the play now thing starts to be a little bit easier. On our context menu, I'm going to get this attribute, but I'm going to use jQuery to do it. So here, I'm going to create a jQuery object. From the element itself. And then I'm going to take that element and I'm going to use the data attribute or the data method to go retrieve my data. I'm also going to modify some stuff here. I'm going to what is it? Has. So you can see one of the effects of jQuery is it shrinks your code down. Okay, so we're using a library to do some functions for us, some capabilities. I still have some stuff I haven't written in here. None of this really has to change. These kind of local functions are just generating some text that I'm treating as markup. And then I'm going to walk through any other components that I have, any other modules that I have. This guy doesn't touch anything. This guy doesn't touch anything in the DOM. This guy doesn't touch anything in the DOM. And that should convert me completely over to jQuery. So the big things, the big ticket items, HTML and append for creating DOM elements. We also have the on method for creating event handlers. Now there's a shortcut for this as well. You should see. That works too. And you can look these up in the jQuery document if you want to see how they fit together. I'm also using the data method on jQuery objects. And I'm using that data method to retrieve information in the data attributes. I can even shorten this up. And you'll quite often see stuff like this. Now the downside of doing it the way I'm showing you here is that every time we call that jQuery constructor, we're creating a new object. So it's a little less efficient. You're trading readability for efficiency. If you find you're using some of this a lot, you can go back to put it in a variable. Come on. Now, if you want to get really crazy, a lot of people will do stuff like this. Put a $sign in the variable name to tell me that it's a jQuery thing. So just kind of a little text reminder that it's a jQuery object and not a DOM element that I'm playing with here. And then again, these guys aren't doing anything different. They're just creating some markup. Right. So, just to flip through that again, as we interact with the DOM, we can use jQuery or vanilla JavaScript. Vanilla JavaScript, we use the query selector and add event listener. jQuery, we use the jQuery constructor, the $, and the on method. We grab the event object, and the target we can then use to get a jQuery object from the target, from the thing that was actually clicked, and then we can use the jQuery methods to manipulate them. The main jQuery methods we use to manipulate the DOM: hide, show, HTML, append. We've got the event handler on, and you'll probably find yourself using add a class and remove class a fair bit. Typically, when we want to change the styling, we don't usually want to go in and change the CSS or the style attribute directly. We want to let our CSS do its job, and that means we typically will build a CSS class for any kind of styling things we want to change, and our JavaScript code will add or remove classes. It insulates us a bit. If we're directly manipulating styles with JavaScript and we want to change what it looks like, we have to go write JavaScript code to do it. If all our JavaScript code does is add and remove classes, and we want to change the look of something, we can just go to the CSS and update the CSS. And it's much easier, smoother, faster. So we typically add classes and remove classes to change the styling on things. When we combine these things together, we get event handlers that let us go find what we're clicking on and then add or remove the appropriate classes to get the look we want. So as we're doing our Minesweeper, you click on a cell, you're going to want to change it from being unclicked in some state to clicked, and then you're probably going to want to add a class to it indicating how many mines are in it. And if there's a mine there, or how many adjacent mines, if there's a mine there, you want to show some mine icon, play the explosion sound, pop a dialogue, do some visual effect. Hey, you blew up a mine, you died, you want to play again. If there's a count of adjacent mines, you want to show how many. And when I'm showing how many, I actually not just use the number, but I use the color. I change the inner HTML to show the number of mines that are adjacent in a cell. Let's see if it's still. And when I select a cell there, if there's adjacent mines, I'm going to show the count or the number. And I'm probably going to change the color with a class that indicates the style. And if I'm clever, I'll make the class name have the number in it so I can put it together with a string. All right. Other than that, we want to be able to pull those data attributes out. Those are our user data, and we want that so that when I click on a cell, I want to find out which cell I clicked on. I want to have one event handler for the entire game map. And I want that event handler to get an event that says a certain TD element was clicked, which one. So I'm going to go grab the target that was clicked, and I'm going to go grab its data row and data column. Why do I want those? because what I'm eventually going to do is go ask the mine field, is there a mine at this row column? And as we start to top-down build this, add mine, randomize, here in my mine field, let's call it has mine at. Right? And now all I have to do is return whether or not I have a mine. That gives me a Boolean that says yes or no, there's a mine there. Now back in my game, when I click on a cell, right? That's handling the right click, the context menu. Let's add the table area when the user left clicks. And then we can do all this stuff. Check for mines. We'll put that together. And to do that, we need the row and column. So what we could do, take this chunk of code and use it again. Of course, as soon as I use it again, I'm thinking, well, hell no. I don't want to use the same piece of code twice. I want to make a method out of it. Right? I'm going to return an object that has row and column. And how are we going to build that? Well, I'm missing a bracket in there somewhere. We're going to take this guy put it all into one. And return an intrinsic object. Right? And now location from event we can reuse. I don't need to do this anymore. I can just use my location object now. And now I can reuse this piece of code the same way here. Now, that target is going to need to modify. So here, I'm going to also need that target. And now we have the basic functionality in jQuery. We're taking advantage of a bunch of the things we can do. Not to mention, we're using our own methods to test our own minefield. I think it's actually lowercase m. Minefield. I'm going to change the name of that to make it easier to read so I don't get confused. There we go. Now, you'll start to notice that init event handlers is starting to get long. So again, this would be a place where I would go into my JavaScript and I would bust it up into sub-methods. And probably I would make the internals. I would make these things call a single method. Okay. So for instance, why is that missing something? Yeah, that's what it's missing. So for instance, I would look at this and go, okay, this is handling left click. And then I take all of this stuff and I put it in here. Format it nicely. And then I just call that guy. And now I've kind of reduced it to a one-liner. And again, I just keep doing this over and over and over again until I get everything that's less than a page in length. I'm going to do the same thing with this context menu for the right click. Do my whole prevent default thing, and then I can get rid of all of this. And now my init event handler starts to become really small and easy to debug. And it just defers things to my handle left click, handle right click. Code. So we just continue to percolate that through. Now, we've already gone through kind of the data attributes. There's a little bit of a sample of it here in the slide deck. This is the place where you pretty much have everything you need to know to complete your entire Minesweeper game. Right? There's nothing else that you need to make the game other than a little bit of time. So you've got from now till the end of the term. Next class, I'm going to teach you a little bit about some stuff that's coming in the next term, but there's nothing in the next class that you need to complete the Minesweeper game, all right? And that said, next week, I'm expecting to be in there physically, so we can help you spend a little bit of time in the class if you're having issues trying to make certain parts work, okay? That's pretty much everything. You know 90% of what you need to know for JavaScript. There's some subtleties and some shortcuts that we'll learn as we go into the next term. But next term, we're going to get into client server. We're going to get into the communication. We're going to build our own servers. And it's not as daunting as you think, but we're not using any new language constructs. We'll use the same kind of arrangement. Right? Cool. That's good for today. Have some fun building some of this stuff. Get some cool stuff going in your Minesweeper games. And have some fun with it. All right. If you have any questions, by all means, message David and I on Discord. Right? David's there, so if you need to drag him back over into the class to help you, feel free. Right? And next week we'll be available to you as well. Okay? All right. Have a good lunch.